Tansei, I'm Dallas Flett-Wapash, an Minnesota video game designer. This is the first part of a 4-video series that will introduce you to the Unity game engine and the process that goes into making your first video game. So by the end, we're looking to have a video game with a character we can move, objects that we can collect, and a video game to beat. While it may sound simple, there are tons of approaches and fundamentals to be learned this way, and so this series won't assume that you have any prior knowledge to the Unity game engine, so beginners are absolutely welcome. This series is part of a larger initiative from Taking It Global in partnership with Imaginative. This initiative is called Create2Learn. To learn more about their upcoming projects, check out their Instagram at Create2Learn or the hashtag Create2Learn. It's a wonderful project to teach youth digital skills. The focus of this series is going to be the Unity engine. So before we begin, I'd like to do a land acknowledgement. This series was produced in Brandon, Manitoba on Treaty 2 territory, the traditional lands of the Cree, Oji-Cree, Anishinaabe, Dakota, and Dene peoples, and is the homeland of the Métis Nation. This treaty was made in 1871, and to learn more, or perhaps learn more about where you live, visit trcm.ca. So, in the first part, we're going to get more familiar with Unity's user interface. We're going to make our own character, learn how code works, and start our first level. If you want to start off on the right track, I'd say to find 2 images in JPEG or PNG format. Any random images will work. And then later on, we're going to be making a character out of separate body parts. So if you want to find pictures of like a hand and maybe the face of Ernest Munias, you could do whatever you want. There's plenty of ways to download Unity. I prefer to download the Unity Hub platform as it helps me keep track of its multiple versions because Unity is always getting updates as the year goes on. So download that, run the installer, and start it up. You'll likely see, for first-time users, you'll get prompted to enable a license. So head to the top right corner of the box and go to Manage Licenses. Unity is free but requires an email to link to run in the first place. Since it's a super powerful software that we're working with, you'll be given instructions on how to do that. So once you're done that, you'll likely see something a bit more bare than what's on my screen. This screen shows all of the video game projects that you have created over your time with Unity. And as you can see, I have a couple. We're going to create a new project. So click on the blue New button and you'll be asked to give the project a name. For this series, I'm going to call it the Create2Learn workshop, I suppose. And you'll want to select the 2D template as this will save us some time configuring things later on. Then you'll want to click on the project's location. Make sure the project is located somewhere you'll remember, so spend some time to figure out where that is. Usually for me, it's my downloads or documents directory. Then right-click to create a new folder for your project, select that folder, and hit Create. So, after a few moments, the engine will open up. Bam! There we go. So, there is a lot of information to take in, so let's take it step by step. At the bottom of the screen is the project window, which shows us where every single one of our files for the video game is located. Currently, we have a folder that contains a scene, and simply put, scenes are video game levels, so you could potentially have a lot of these for a game that has like a bunch of levels. Many types of files work with the Unity engine: videos, images, music, sound effects, and so much more in so many different file types. I've made my own picture of a star blanket and found an image of a green lobster from the internet. Putting them in the game is as simple as locating the files on my computer, the same I would with music, documents, or selfies, and doing a click and drag for them both into my project. So find or create 2 images in JPEG or PNG format, like I said earlier, that you can play with, so you can follow along. This brings us to the right side of the screen, which holds our Inspector tab. When I click on my file in the project window, the inspector tells us everything we want to know about our files and even our game objects. It shows us what we're able to change and lets us make any changes we might want to at that given moment. Now I'm going to make game objects out of these 2 images. I do this by clicking and dragging these 2 images from my project window to the scene where our scene hierarchy is. The scene hierarchy shows us all of the game objects in our scene, and for more complicated games, a lot more. You can see that clicking and dragging my images made 2 new game objects and that I already have a main camera game object. Game objects are pieces of information that exist somewhere in our level. On their own, they don't do much and simply exist, visible or invisible, within our level. In the center of the screen is the Scene window, the Asset Store window, and Game window. The Scene window allows us to make changes to our game objects. The Asset Store window allows you to buy or download Unity assets, which we won't be doing for this series, so you don't have to worry about that. And finally, the Game window, which shows us an example of what our finished game would look like. In the Game window, we can't make any changes because it's showing us the end result of what we've made. Back in the Scene window, I can already see that my star blanket is looking super fuzzy. That's because it's actually a really tiny image, and Unity is trying to blur it to make it look smooth. I don't like this so much, so I'm going to go to my project window and select my star blanket. Then I'm going to check out the inspector window options for my star blanket picture. I want to change the blur filter, so I'm swapping it from bilinear to point, which is no filter. This is a small but important step if you were wanting to work with pixel-based art for your game. I also want it to be bigger, so I'm spreading out the amount of pixels per unit that my picture takes up. Instead of 100 pixels per unit, I want 32 pixels per unit to spread it out. When making these changes, I hit apply and they finalize. So let's go over some quick keyboard shortcuts when navigating the scene of our game. Pressing these shortcuts on our keyboard will make things a lot faster for us to work. In the Scene window, press W on your keyboard to use the Move tool, which allows you to move your game objects. Press E to use the Rotate tool to rotate our game objects. Press R to use the Scale tool, which lets us size our game objects however we want. And click on the middle mouse button to move around the scene. You can also zoom in and out using the mouse wheel. And those are probably the most important keyboard shortcuts that you'll want to know. You can also press F to find any game object within your scene in case you get lost. So we can see as we're altering our game objects, their position, their rotation, their scale, we can see that those changes are being reflected in the Inspector tab. The transform, which is a component, is changing as we move, rotate, and scale our game object. So as you see, all these numbers are changing. And oh no, I've lost my lobster man. The reason this is happening is because my two pictures are on the same layer. This can be very confusing to the camera because two things are clamoring for its attention. So what we need to do is have them operating on separate layers. Fortunately, our game objects, the two pictures we have, are automatically given a sprite renderer component. Components are what give our game objects any semblance of functionality. We can see all of that information in the Inspector tab to the right. And from a quick read, we can see that the sprite renderer component works with sorting layers. So we need to change the layers that both of our images are working on. Currently, they are both on layer 0. You can see that me making changes to the layer impacts whether we can see the lobster man or not. Awesome. Our lobster man is chilling with his star blanket for accomplishing something great. Side note, I was gifted a star blanket from my Nookum for graduating college, so cool. Alrighty, so I want to explain how our project works with files. It's a bit of a constant relationship, so any changes that we make to our file will be shown in the final game. I'm going to use Paint.net, which is a free alternative to Photoshop, to demonstrate this relationship. I'm going to click and drag my project's copy of the star blanket and put it in Paint.net. Then I'm going to change the indigo to a more pink color. Once I save that change in Paint.net, Unity will refresh after a couple seconds. Bam! Now it's pink. A really flat pink. And we can see that the original star blanket that I copied from earlier remains unchanged. I hope this conveys that any file that we click and drag into Unity is copied, so two types of that files exist in your computer. Next, we're going to discuss the parent-child concept. Video game characters often animate inside of their games, and it would be super time-consuming to individually animate and move every single body part of that character, especially in huge levels. So you can see that my two pictures are moving individually because they aren't parented to each other. Children follow their parents wherever they go, at least in the game sense. So to move these two pictures together, I need to click and drag the lobster game object onto my star blanket object. This will create a parent-child relationship with the file. Children can still move freely in relation to the parent, but wherever the parent moves, rotates, or scales, the child will too. Oh, what? That's pretty neat. I'm going to take some time to make individual body parts for my video game character. Feel free to make your own art with something like paint.net or find something online. My challenge for you is to use all that I've taught you so far to make your own video game character. Moving, rotating, and scaling images, changing the order of the layers, and making a character with 2 hands. That'll take some time, so check back here once you've got some images or made pictures for your character's body parts. Doesn't have to be a masterpiece. You could totally just find a PNG of Ernest Munias, which is a masterpiece, or find a PNG of some gloves too. We just want a character with arms. Alrighty, so after some time, I've made a beautiful Napadak, which is a potato who has a hat and gloves. Using my own pre-made art, I made this character, and I can move my Napadak all at once, and I want to create what's called an empty game object. Empty game objects are game objects that can be used to do whatever we want. They are blank canvases to add things to. So I'm going to create an empty game object and parent it to my character. So I'm going to create an empty game object by right-clicking in my scene hierarchy. And then I'm going to click and drag all of my game objects for my character's body parts and drag them into that empty game object. Cool. I can move my character all at once. This empty game object is where I'm going to place all of the functionality for our character. I'm going to click on it in my scene hierarchy, wait a second, and rename it to player. I want to give this game object some semblance of functionality, and I know to do that, it needs components. To add components, I click on my player game object and look at the inspector. There's a fancy little button called Add Component. Clicking on that shows me a list of all the components that Unity currently has installed. It's a lot, since you can heavily customize the purposes of many game objects. I want to add a capsule collider, as that's most like the shape of my character. Yours might vary. There are circle, box, and capsule colliders to choose from, so ensure that what you have has 2D at the end of its name for the component, as collisions are different in 2D spaces compared to 3-dimensional ones. I also need to add my own code to this character so I can get it moving and doing stuff. Code is written inside scripts, and scripts are components that we make ourselves. I'm going to add another component and type in the name for my script. I'm naming my script Create2Play. Odds are no components will show up because none have that name, and I'll create a new script with that name. Doing so added a component to my game object and created a new file as well. Double-click on this file to open it up in Visual Studio. For first-time Visual Studio openers, Visual Studio will need to register with an email, just like Unity. It's all free, but needs to be registered with an email to run. Once all that is handled, Visual Studio will open up with your script shown. A lot of stuff is written already, so we're going to take it step by step, just like the user interface that we just did. We see system.collections, collections.generic, and unity.engine. These are libraries of information that contain a list of commands that we can use within our game. Our code is just saying here, hi there, I need access to these libraries for what I'm doing. Most important is the using unity.engine, as its library has specific commands and stuff to use. The green text is what we call comments. Comments are just things that people can write within the code without it being read on the game engine. To write these, you make 2 forward slashes and then just type a sentence. This lets us clarify what's happening in our code at any given moment, and when. Below that, public class Create2Play refers to the name of our script and its nature. The word public means that our script can be accessed by other things in the game engine. You'll notice that underneath that line of code is a curly bracket. This next bit is a bit important. Essentially, curly brackets are used to contain information. Usually things created within a set of curly brackets cannot be accessed from another set of curly brackets on that same level. Imagine my thumb is the opening curly bracket and my pinky is the closing curly bracket. If I create fingers within these 2 curly brackets, I can't access them from another set of curly brackets. Curly brackets end up creating a hierarchy that establishes what they have access to, and this hierarchy is implied through indentations within the code. You can see the void start function and void update function have curly brackets on the same line, meaning anything they make cannot be accessed to each other. However, the curly brackets that are less indented, like the one underneath public class, can access both of these functions and what they make. This is called scope. You could think of it like an umbrella that's sheltering 2 smaller umbrellas. The big umbrella has access to the 2 smaller umbrellas' stuff, but the 2 smaller umbrellas don't have access to each other. This may be confusing to first-time coders, but in time it should become second-hand knowledge, like make and bannock. So Unity has given us two functions to start with, the start function and the update function. Let's make our own to understand how functions are written. I start all of my functions with public so that hierarchy doesn't really matter and the engine can access the function whenever I need it to. Then I add the word void to specify that I don't want this function to bring me back any sort of information like numbers or words. I really just want it to do something. And that thing it does is going to be kept entirely inside the brackets. So anything outside of the brackets won't be done by my function. I really just want it to do something. So I give this function a name. In this case, I just called it my function, which is capitalized just like start and update. Then I add an empty set of braces. The braces are used to specify any parameters for this function, but we don't need to worry about that right now. Then I create a set of curly brackets. Noticing the hierarchy of brackets, I want these brackets to be indented the same amount. Now, functions are used to do something. I'm going to use this function to log a sentence to better understand the start and update function. We can read that start is called on the first frame of the video game, so it sounds like something that's only going to happen once. I'm going to call my function here with an empty set of braces and a semicolon. Semicolons are used to end lines of code so the engine knows when to move on and doesn't get confused. I'm going to go add something to my function. From memory, I know that the Unity engine library has the debug class, which is a class with its own commands. To access these commands, I use the period. The period is called the initializer and shows me all of the components that this class has. Using the arrow keys, I can navigate all of these commands, and there's a bunch. So for now, we're just looking for the word log. From hovering over it, I can see what the command's intention is and get a vague idea of how to write it. I can see that this command is used to log a message to the Unity console and that I need to write a message within braces. If you were on your own learning this, I would Google examples. So I Googled debug.log and I found that Unity has an online scripting API that documents examples of how to write stuff. From going there, I can see that this coder used quotation marks to write their sentence. So that's what I'm going to do. And if it works, then oh what? On my keyboard, I press the Control button and S at the same time to save my file, just like in Microsoft Word or something like that. Unity will refresh after a couple seconds. Right now it's reading our code to catch any errors, but since I'm flawless, I have no errors because I'm perfect. At the top of the screen, I'm going to click on the play button to run my game. At the bottom, there is the console window. Nothing shows up until I clarify that I want to see debug logs. And from doing that, I can see that, oh what, it works. It happened once as the game started up. Now, let's move this command to the update function and see what happens. From what the green line says, I can guess that this function is used every frame of the game. Games often run at 60 frames per second, but can often also run at 120 frames per second or even more. So this will probably happen a lot. Control.S to save. Unity refreshes and lets us play our game again, and oh what? It works a lot. My function is being called every frame because that's what update does. Alrighty, so we covered a lot of ground with this first part. In the next segment, I'm going to get our character moving, paint a level, and learn some more code. I'm not Alice, I'm Dallas with a D, and we'll see you then.